Okay, welcome back to our class for Prelim Week Module 1. So for the objectives or outcomes for this module, so at the end of this module, you must be able to first is discuss the principles of lightning protection, multi-velocity waves, insulation coordination, application of surge protection devices, and power system grounding. So, kani sa klase nato for our subject, so continuation sa inyuhang first sem which is ang power system protection 1. So, sa protection 2, nag-topic siya about symmetrical three-phase fault calculations. So, according to the method of symmetrical coordinates applied to a solution of polyphase network, a system of vectors or quantities may be resolved when is prime in two different symmetrical groups or system, one of which consists of equal vectors and the rest n-1 system consists of equispaced vectors which with the first mentioned group of equal vector forms. So, sa symmetrical fault, we have here, so symmetrical fault occurs when all the three conductors of a three-phase line are brought together simultaneously into a short circuit condition. So, this type of fault gives rise to symmetrical currents. So, example given is equal currents with 120 degrees displacement. So, the symmetrical fault rarely occurs in practice as majority of the faults are unsymmetrical. So, mostly sa TUA, sa mga EE, ang symmetrical fault are panagsara. So, mostly sa TUA is unsymmetrical. So, it is the most severe fault and imposes more heavy duty on the circuit breaker. So, how to solve? So, natay steps in solving three-phase fault calculation. So, for the step 1 is draw one line diagram of the network indicating the rating and per unit impedance of each element of the network. So, first we need to draw our one line diagram. Here, makita na to, we have our Gen 1, our Gen 2. So, sa Gen 2 na to, so naa ato ang transformer dire and naay transmission line. So, before siya maabot sa tong transformer, so atong fault, so mostly unsymmetrical man. So, we have here our fault. So, after na to, makadraw sa atong one line diagram. So, step 2, we need to choose a numerically convenient value of base power and convert all per unit impedance to this base value. So, after na to makadraw, we need to convert all per unit impedance ato ang base value. So, for our formula, we have here impedance per unit is equal to the base power multiply sa ato ang impedance nga ohmic nga given divided by sa ato ang voltage base squared. So, please memorize this. So, important formula. So, after na to, so we need to convert. So, to convert, so na new na ato ang impedance base value. So, impedance per unit new is equal to the impedance base value which is katong old ganina multiply sa ato ang base power nga bag-o divided by sa atong base power nga old and multiply sa ato ang voltage base which is old divided by voltage base new raised to the power of squared. So, So after na to, ma-convert ang atuang per unit impedance. So proceed ta for our step 3. In reference to the one-line diagram of the network, draw the equivalent impedance diagram showing one phase of the system and the neutral. So indicate the per unit impedance on the base power in the impedance diagram. Transformer are represented by a series per unit impedance in diagram. So after na to, maka one line diagram sa itong network, dapat i-draw na to ang iyahang equivalent impedance na showing na naka one phase of the system and the neutral. So we have here the neutral line. So sa impedance sa ato ang katong gene 1 na to ganina, ang impedance sa atong gene 2 and the impedance of our transformer and the transmission line and our fault. So for the step 4 is find the total per unit impedance or ZT of the network up to the point of fault using the circuit analysis. So we all know total unit per impedance is equal to the Thevenin's equivalent impedance. So three-phase fault is calculated using Thevenin's theorem. So familiar na tani sa magian nato ni siya sa atuang circuit 1. So in step 5 is find the base current or I base corresponding to the selected base power and the normal voltage at the fault point. So we have here our formula for our base current. So I base is equal to the base power divided by the square root of 3 multiply sa tong E voltage point. So memorize po for the important formula. And lastly, for the step 6, the various faults current are then calculated. So for our last step, so we have here, makita nato ang ato ang circuit. So we have our total impedance. Our total voltage is equal to 1 per unit and our fault current. So IF is equal to fault current and SF is equal to fault power. So formula for our fault current, if per unit is equal to 1 over CT. And formula for fault current, we have also IF is equal to IF per unit multiplies ato ang base current. And to solve for the fault power, we have SF is equal to the base power over ZT. So take note for this important formula. Kani magamit ni siya sa tuang board exam. So let's have an example for our topic today, which is symmetrical three-phase. So we have here two alternators rated 15 megavolt ampere and 20 MVA have per unit reactance of 0.30 and 0.50 respectively, are connected to a common 12 kilovolt bus bar. Solve the fault current if a symmetrical three-phase fault occurs at the bus bar. So on step 1 na to, we need to draw for our one-line diagram. We have here for our Gen 1 and Gen 2. So makita na to dire. Our Gen 1 and our fault and our bus bar. So after na to, makadraw. So step 2 is assume a common power base of 20 MVA and convert all the per unit reactance based on this power base. So we have G1 new is equal to 0.3 we have here 0.3 times 20 MVA common base power over 15 MVA. So our impedance new is 0.4 E per unit. So after, for our step 3 is we need to draw for our one-line diagram. We have here our one-line diagram. So we need to indicate the per unit impedance for G1 and G2 and for our total impedance. After that, so for our total impedance, we have 1 over ZT since nakaparallel. So 1 over, ang given is 0.4 plus 1 over 0.5. So nakaparallel circuit sa ato ang one line diagram. So our total impedance will be 0.22 per unit. So to solve for our fault current, since naanatay total impedance, so pwede na tayo makasolve for our fault current. So IF is equal to 1 over ZT, where our ZT is 0.2252. So our fault current will be 4.5 per unit. But ang unknown na to sa itong problem is solve the fault current if a symmetrical three-phase fault occurs at the bus bar. Since naka per unit, so we need to solve for the base current. So I base is equal to formula base power divided by square root of 3 base voltage. So sa itong problem, naghatag siya og common power base nga 20 MVA. So we have 20 times 10 raised to the power of 6 divided by square root of 3, and our base voltage is yatag common nga 12,000 volts. So our base current will be 962.25 ampere. Since nanatay base current, so pwede na nato ma-solve ang atuang fault current. So we have here IF is equal to IF sa atuang per unit multiply sa atuang base current nga na-solve ganina. So substitute. So we have 4.5 PU multiply sa atuang I base nga 962.25 amperes. So our fault current will be, so calcu, we have 4,330 amperes. So this is our final answer. So I hope nasabtan for our topic this week, module 1. And if you have any question, you can comment sa atong Google Classroom para matabangan nima. So that will be all. So thank you.